this is your packet from yesterday. This is the worksheet you picked up today. I'm going to come by and give you a stapler to staple the sheet to the packet. Okay, staple it to the back of the packet for me, because we're going to talk about the breakdown of the test as well. So if you're out of staples, if there's an issue with the stapler, just let me know. But you need to staple this worksheet, the practice 2, to your review packet. You're going to need your review packet today. This part was added to your review because you're going to have some dimensional change problems. This is what we went over, not yesterday, but on Monday, okay? So I'm going to hold this and give it to you at the end of here. So yesterday, the other day, we looked at how to change. There's a rule that you're going to have to know for these type of problems. There's one way you can work this out, because this one gives you a picture already. It says that if you reduce the length of each side of the square by 1/2 of its length, what is the effect on the area of the square? So I can reduce the square to 1/2 and make it smaller. That means that the new size would be what? 10. If this is 20 and reduce it by 1/2, that's 10. So you need to find the area of this square. This is 400, because you do base times height. Then you need to find the area of the new square, 100. So the new square is blank times the area of the original square. How many times is the new square to the original? Yes. But it's a square. So if it's a square, right, if I do the length, it's going to be the width too, because all the sides are the same. Okay. So the new area is blank times the area of the original. So you're saying 100 times 1/2 would give you 400? It's 1/4. Yeah, it's 1/4 times. Okay? It's 1/4 times. If I did 100 times 1/4, okay? I mean 400, sorry, because it was the original. The original is 400 times 1/4. You have to screw the top. Unscrew the top. That would give you 100. Okay. So I need you to add this to your sheet, because there's a rule you need to understand. This is a fact you need to memorize when dealing with change in area, okay? So for area, whenever you're dealing with area, you will take the change amount and you're going to square it. I know I'm running out of room. You're going to take whatever the change is happening to the shape and you're going to square it. So, for example, in this first problem, they told us that the problem was that the square was going to change by 1/2. Does everyone understand the change amount is going to be 1/2? All right, so if I did 1/2 and I square it, so you might want to write this down too, 1/2 and then square it. You square the top and then you square the bottom. This would end up being 1/4, which is the same answer we got down right there. That's the pattern, that's the rule. So if you take the change amount and you square it, that'll tell you what you're going to multiply to the original to get the new. So, on number 2, and I know there's a typo, it says the radius of a circle is triple to create a new circle. What is the ratio of the new area to the area of the old? It says the new, and that should be circle, is blank times the original. You triple and you square that, and that would be 9, right? So it would be 9 times the original. Yeah, 9 times the original. All right, so taking it one little step further, let's change this 16 to 18, because then it'll come out a little bit nice and neater. You can still get an answer, but I just want it to be 9. It's 9. right, so a triangle has an area of 18 centimeters squares. It is reduced by a scale factor of 2/3. Yeah, change it to 18. I just said that. I just said that too because it'll come out easier and neater if we do 18. What is the area of the new triangle? So how is it changing? By 2/3. Okay, so this is the change. What do you do to that change? Square. Okay, if you square it, what would you get? 4/9. Okay, so basically, I'm going to take my area, 18, and I'm timesing it by 4/9. Yep. If you do the 18 and times it by 4/9, you get 8 centimeters squared.
You know I was sharpening my pencil.
I know. But you're looking through the packet. I'm just trying to help you out. All right, so you have the next three. There's a true or false, and then the other two are multiple choice. See if you can pick the right amount of change. 4, 5, and 6 is yours right now. All right, so the whole packet if the whole packet is finished, it's 5 extra points. We're gonna go over some in class right now. Okay, so hopefully you can check your answers. You know how to do these type of problems. Oh, on the back, this I just wanted to show you quick. I'm about to post it right now. I will have like some slides to kind of train yourself what to do for each problem. If you want to look on those on Emoto, this is just a blueprint of how the test is going to go. It tells you how many questions you have of each, what you need to know to do. We're going to look at the test-like questions off the review packet. So we've already did these. We did these yesterday. All right, number 7. Go ahead and circle 7. Yes, I do want you to leave it in terms of pi. So you're giving me the circumference and the area in terms of pi. Okay? So I'm going to probably do one of each so you have an example to look at if you want to finish the packet for extra credit points. So in terms of pi, our formula for circumference is 2 pi r, and our area is pi r squared. So we're going to leave your answer with the pi in it. Anyone have 7? Matthew. 28 pi. Questions on how he got that? We're on number 7. Yeah. Now area. 14 squared. You would do pi 14 squared, but when you do 14 squared, so you get 196 pi. Pi goes at the back. 14 squared is 196. So you just put the pi to the back of the number. The 196 is a coefficient. I don't know. I'm just assuming. I'm just assuming. That's all I'm doing. That's probably wrong on me. All right, so on number 9, what formula would you have to use on number 9? Because I'm not going to work this one out. For area, you would have to do base times height divided by 2. Okay, so if you look at your picture, do you have the base? Okay, do you have the height? The height is what you have to find. So what's happening to the base? It's split in half. So this would be 3 and 3. So now you have to use Pythagorean theorem to find the height. Okay? Now, the test light, the one you're going to see that's similar to the test is 10 and 12. You're going to see one like 10 and one like 12 on the test tomorrow. So, when dealing with these type of problems, there's not just one way to solve it. Can I? Okay. On 10, what could you do to get the composite area? Cut it right here? Okay. So this would be 10 right here. All right, so we have a 10 by 5. So that's 50. And then we have a 15 by 10. Yeah, so the area is 200, yes. 200 centimeters square. All right, try 12. Like I said, I'm gonna try to do half so that you have a problem or something to look at, and you can do the other ones. How can we cut 12 up?
Make that a square.
Here, and then down. Okay. Okay, what you do, Matthew? It doesn't matter. You can cut it up different ways. So you just went this way too? Yeah. Okay. You could go either way. How? What? How are you gonna get just two shapes? Okay, and then don't cut this one. How are you gonna get the area of this L shape? Okay, so this one we know is a 14 by 4. But if I cut this way, what's the dimensions for the middle rectangle? Yeah, 7 and 5. This would have to be 5 because 3 plus 5 is 8 plus 6 would give you the total 14. So this is 7 by 5. And then the last one would be 4 by 11. Yeah, 4 and 11. That is right, Bobby. Give yourself a point. 135. All right. On this page, number 14. 14 has several steps. Now, on 13, do y'all see it's divided into fours right here? Yeah, the area by 4. Like this is 16, so this would be 16, right? So are you dividing like this by 4, like 4, 4, 4? Because it's a square. So, and this getting cut up.
Can't you just divide it by half? Because half of the shade is half.
Yeah, so this would be 8 and 8, right? Yeah. Yeah, 128, yes. Okay. All right, now let's talk about 14 real quick, because this is more like the test. Okay. All right, so we're trying to find the area of the unshaded, okay? So we have to come up with a plan to get to that. All right. I'm hoping you look at that you're definitely going to need the area of the rectangle. That's base times height. So we got to have the whole part. So that would be our basically 25 times 12, 300. Now, from there, we have to take off which parts? If I want just the unshaded, yeah, we got to do the triangle. So we have the small triangle, base times height divided by 2. Okay, so if I want the small triangle, think about this. If I know this is 5, this hypotenuse is 5, and this is 3, what would this part here be? I'm sorry, this is 4. This would be 3, sorry. So what remains up here? If this is 3 and the whole thing is 12, that's 9. Then I'm going to go over here. The size is what? 12. Yeah, this side is 12. Yeah. Yeah, this side over here is 12. Exactly. This is 8. Pythagorean triple. Pythagorean theorem. Okay. This right here, yeah, this part is 21. And this over here, 13. Huh? Here would be 9. Yeah. To get, again, this is a right triangle. I'm going to do Pythagorean theorem to find the missing part. So for the small triangle, we have 3 times 4 divided by 2. And then for the large triangle, the big one, we have 12 times 9 divided by 2. So this one is 6, and this one is 54. Yeah, unshaded would be 240. Yeah, you'll have a shaded and unshaded. That's why no. It never looks like the same problem. Okay, so basically to get you had to add these together. That would give me 60, and then I subtract it. So that gave me 240. That was the unshaded. 15 we're going to omit because you can't see it. I can see it, but you can't. Omit 15. And we're doing this page together. 17. Go to page 7. Go to problem 17. Okay. All right, now find each missing variable and angle measure. So, who remembers the formula to help find the angles? Because that's the first thing you have to memorize.
Like 360 divided by half the size?
Yeah, 360 divided by the number of sides. No, times 1/2. You take half of it. Okay? All right, so I'm going to just tell you right now, this part right here, you need to memorize because it's not on the formula chart. Yes. Yeah, you could, or yes, you could say divide by 2. So you could or say 360 divide by n and then divide by 2. Yes. Okay, times by 1/2 or divide by 2. Okay, so see if you can come up with angles 1, 2, or 3. So close. No, angle 1's not 15. No. Angle 1 is 30. Angle 1's 30 because if you do 360 divided by 6, that's 60. But if you take a half of that, that's 30. So that's angle 1 is 30. 360 divided by 6. 6 is the number size. Huh? Angle 3 is okay. So what did you say for angle 3? Times it by 2. So yeah, from the first angle. So angle 3 is 60. All right. So if angle 3 is 60, what's angle 2? It's also 60. All right. Now, what is the radius? Always start with your radius. Yes. That's why I'm doing these. Huh? The radius is 24. This is the other thing you need to memorize. Yes, the radius for a hexagon is the same as the side. All right, so the radius, no, the little a is the apothegm. Okay, so if this is 24, then the radius would be 24. Right here, this is also a radius. The hypotenuse is 24. Huh? No. Yeah, it'd be 12 root 3. So you take that radius, the apothegm cuts this side in half, right? The side is 24. So every apothegm cuts the side in half. So this would be 12, and this is 12 root 3. Do y'all see a pattern between the two numbers here? If I know the radius, if the radius is 24, then the apothegm is going to be half that root 3. So what if your radius was 10? 5 root 3 would be the apothegm, okay? If your radius was 16, then 8 root 3 was your apothegm. What if your apothegm is 4 root 3? Then what would your radius be? 8. Okay, y'all see the pattern? All right, so right now, 4 points. See if you can do 18. It's the same type of shape. I just changed the numbers. Yes. Yeah. Mm-hmm. Yeah, that angle. Cameron, I need you to kind of like. Okay, all right, Matthew, what'd you get for X? Yeah, that's 30. P got 8. Yep, 4 root 3. Oh, you're right. I wrote wrong letters. This is 4 root 3. This is 8. If this is the radius, it's the same as the outside. Yeah. Okay. With that, now let's look at 19 real quick. 19, they've labeled the parts for you. What is the A? The 17.3. What is the S? The side is 20. Okay, so find the area when it's a regular polygon. You have to do 1/2 times A times P. Or you could say apothem times the perimeter divided by 2. So which part do you have to find in this shape? The perimeter. You have to find the perimeter. All right, so to do the perimeter, I'm just doing, 20 times 6. So what's the perimeter of this? 120. So I'm just going to plug it in. I'm going to do the 17.3 times the 120, then divided by 2 to get the area. Yeah, for all shapes to get the area, yeah, you're going to use that one. Yes. Divide by 2. Like you put the answer. Like once you put that in, you actually multiply it and then divide it by 2 and get the answer. Okay. All right. So look at 20. This is a hexagon with a radius of 14 meters. Okay. So I know they didn't draw it for you, but get in the habit of drawing your apothem. It's going to bisect the side and drawing the radius to have a right triangle. The S stands for the side. Okay, so if the radius is 14 and this part over here represents the apothem and it's a hexagon, what would that measure of that apothem be? Yeah, 7√3. It's just half the radius. No, you just keep the √3. Now, if I know the radius is 14, the side is also 14 because it's a hexagon. All right, so a problem like this, we're going to do 1/2 times the apothem times the perimeter. Okay, what is our perimeter for this hexagon? Yeah, 84. Questions on how we got 84? Just did 6 times 14. All right, so we're going to plug it in. 1/2 times 7√3 times 84. Now, the numbers that you can multiply together are the 7 and the 84. Okay? What does that give you when you do 7 times 84? 588. Yes. Then we're going to divide it by 2 and then put, what was that? Yes, 294√3. Okay? You just add it to your final answer. When Avery gets back. All right, so I need you to try 22. This is what we've been working on. I need you to try 22. What do you mean you have to factor the √3? You have to show me an example. I don't think you're describing it right.
It's like they would say multiply 216 by that.
Oh, to give the approximate answer. That's just in pre-cal you do a lot of approximations. This triggers a bunch of approximations. Okay. All right. So if you know that this triangle has a perimeter of 36, could you figure out the sides?
Each side is 12.
Yeah, each side is 12. Okay.
That triangle is 6, the base.
This little part right here is 6. Could you get, this is your apothem, right? The base gets cut in half, 6 and 6. Huh? No, the apothem is the perpendicular one. This one is the apothem. Which one is the radius? The hypotenuse is the radius. Okay. Now, let's work this out so it's easier. Do y'all know how to do base times height divided by 2? For a triangle, base times height divided by 2? Okay. In this triangle, do you at least have a base? Yeah, the base is what? It's the 12. Okay, so the base is 12. The height is not 12. That would be the height. How could you find that height?
Half of the base.
We just did this problem.
But we don't have to read.
Think of it. This is, I'm not doing a pothum. If I was doing a pothum like we did the hexagon, it would be the same thing. But, yeah, so if this is 12, this was 6, right? So what would this end up being? No. No. Look at this triangle right here. 12? Yes. So your height is 6 root 3. So basically you're doing 12 times the 6 root 3, and then you're taking half of the answer. Take half of that. 36 root 3 would be your area. 36. 36 root 3. I did. I had 72. 12 times 6 is 72. Don't divide twice. Okay, so on 25, is there a picture given? No, so draw you a picture. It's an equilateral triangle that has a perimeter of, yes, each side is 10. There we go, 10, 10, 10. If I do base times height, divide by 2 to find the area. Yes, the height is 5 root 3. Yeah. So we did 10 times 5 root 3 divided by 2, so 25 root 3. But we don't have a radius, that problem. We only have radius when you're dealing with a regular polygon. Over here, this had a radius. It went from the center. The height, because if this is an equilateral triangle and this is 12, this is 6. The base gets cut in half. So that's 5. So that would be 5 root 3, because this is 30 and this is 60. Okay? All right, we're going to move on to here you have to draw a picture if there's no picture given, but I want to talk about the last section of your test, which is geometric probability. This is what we did yesterday. We're going to do a couple and then do a game on the way out to add points to your score sheet. All right, so find the probability that if you throw a pebble, it will land in the shaded region. Okay, so basically to find that probability, you have to do the area of the shaded over the total area. Area of the shaded over the total area. Okay, so how can I find this area of the shaded? Think about it. Yeah. 170 is the whole thing. You're right. 170. So we know this is 170. Okay, that's the whole thing. How can I get just the shaded? Yeah, we got to subtract the white triangle. Does that make sense? Okay, so I'm going to take this 170 minus the base times height divided by 2. I'm going to have to subtract this triangle. Now, think about that. If I draw the height, could you see what the height measure would be? Yeah, it's 10. So basically, we're going to do 170 divided by 2. So it's basically half. You're right. So, because this would be 170 this minus 85, which would just be 85, right? Yeah, it would end up being 1/2, because 85 over 170 is reduced to 1/2. You're right. We just cut it in half. Does that make sense? Okay. All right. Now, for this one, this is what's the probability if you throw a pebble and it would land in the shaded region. So how are we going to get the shaded region for this one? I got to find the area of the hole. Again, take the shaded over the total. Yes, this whole thing right here is 15, so we're going to do 15 times 8, but divided by 2 because it's a triangle. That would give me my area. You got what?
60?
Yeah, 60 is your total. All right. Now, who do we need to subtract from that total? The area of the small triangle, which is the 5 times 8 divided by 2. That's 20, right? Okay. So my ratio, 20 over 60, which reduces to 1/3. Yes. Okay. So are we okay with finding geometric probability ratios? All right. There is a partial key already on Emoto where I kind of explain how to do some of the problems to help you to get your extra credit, along with the review slideshow. If you have a smartphone and you want to get points added to your score, yep. Okay. Get out the phone, put in the pin number.